Hi, I'm Steve Sloka, and I wanted to give you a quick overview of the Elasticsearch operator. This operator's goal is to help you to deploy Elasticsearch clusters to a Kubernetes environment. This is modeled after the work that the CoreOS team has done, and they have two operators currently, which is the etcd operator and the Prometheus operator. So I want to give a quick thanks to them for all their work and inspiration for this. Also want to give some thanks to Paulo Pires and his work on the Kubernetes Elasticsearch cluster. Much of the underpinnings of this controller that we've written is using a lot of his work. So thank you to Paulo and Repo and all the people that have contributed to that. So you can find the operator here on GitHub at UPMC Enterprises/Elasticsearch operator. And this was written towards AWS in mind, because that's where we deploy here at my company. But it's going to be easily extendable to other clouds and as well as Minikube. And there should be some open issues you can follow along to see the progress on that. Right now, it does require a 1.5 cluster, and that's because we're using stateful sets and we're using the dynamic volume provisioner. So we'll be able to provision EBS volumes dynamically and create the associated persistent volumes and claims against that. We can also snapshot indexes out to AWS in S3 buckets, so we can persist those indexes there in case of a failure or we want to restore those. Cool, so let's go ahead and take a look at how this works, right? So if you're not familiar with third-party resources, what this does is these third-party resources allow you to extend the Kubernetes API and put your own custom objects in there. So if you say get third-party resources, you'll see there's no resources found. So what we can go ahead and do is create our controller. So real quick before we do that, we'll see that my cluster here doesn't have anything in it, right? There's no pods, there's no services, there's nothing, just to prove that it's a blank cluster. And also we can prove that it's a 152 cluster here, just for reference, right? So what we can do is we'll go ahead and create our controller. So we'll go ahead and run that through. And what we can do is now we can say get pods, and we'll just verify that this spins up correctly. Oops. Okay, so here you can see them spinning up. And what you'll see here is it says third-party resource was not found, we're creating. So again, this controller will go ahead and create that third-party resource for you. So now if I say get third-party resources, I can see that I now have a custom type of this Elasticsearch cluster. And what makes this cool is normally you would say kubectl get pods or kubectl get services, right? And those are things that kube knows about. But now what I can say is kubectl get Elasticsearch clusters, right? And it knows what that's like. So if you got something that it didn't know about, if say I got foo, it would say, hey, I don't know what that type is. So Kubernetes knows what type this is. It's just a matter of us defining it. Great. So now that we've defined that, what we can do is go ahead and get running. So again, we can follow along out here on the repo. Real quick before we get running, is I'm going to verify that my S3 bucket is empty. So we'll prove that that guy's empty. So, oops, I got some stuff in there. So we'll go ahead and just trash that. Now we're empty, right? Cool. So let's go ahead and create our example cluster. So what that looks like, something like this, right? So in this JSON file, you can see that we've defined the API version, which is again against that custom third-party resource. And here's that type. We're going to give it a quick name, example ES cluster. Here we can define how many client nodes we want, how many master nodes we want, how many data nodes we want, and then where those data nodes are going to be persisted to. So in AWS, when you create an Elastic Block Store or an EBS volume, you're tied to that zone that you deploy to. So here we want to evenly distribute those data nodes across those zones, and we can do that here with this little array. Now within that, when we create these volumes, we're going to create them of this size. So I'm going to create a 10 gig volume. We'll enable snapshotting, so we'll turn on the manager, and we'll dump those snapshots here to this S3 bucket, which we just saw. And we'll set up a cron. So we'll say, hey, every 2 minutes, let's snapshot these the indexes out to that S3 bucket. Also, you can define the type of EBS volume you want. So general purpose is what we'll go with. And then here's the provisioner. So here we're going to do EBS volumes, but we can also set it up to do, Google's cloud volumes as well. Okay, so let's go ahead and create this. Let's see our cluster come through. So again, we have nothing in here now short of our operator running. So now we'll say kube control, and we'll create -f, our example cluster. And now what you'll see is a whole bunch of things will pop in here. So what happened was we created a third-party object, and now we have that resource in the API. So then the controller saw that, or the operator saw that, and it took action. So it went and created us 3 clients, which you can see here. We have 3 data nodes, and you can see those are spread across zones 1, 2, and 3. And we have 2 masters. Now, with these data nodes, you can see down here that we have 3 persistent volumes that were created, and we've claimed them with these claims down here. And they're all provisioned with that 10 gig size that we defined earlier. Right, so at this point we have a working cluster. Right, everything is up and running. We've spread our data nodes across the zones. So let's go ahead and just do a quick test, right? So I'm not sure if I found a bug with kube control, but what I'm going to do is I'm going to create a tunnel out to the Elastic cluster through my Bastion box. So my cluster is currently deployed with a NIST template where we have a Bastion access through to all the private nodes. And here you can see here's the nodes in my cluster. So normally what we do is I'd say kube control port forward to the pod name, and then we would give it a port. But what we're going to do is I'm just going to go ahead and edit the service Elasticsearch. And I'm just going to put a quick node port on this, and it'll let me get access to it. Cool. So if we describe the service now, we'll go ahead and get this. And then this is one of my nodes, so we're going to create a tunnel through my Bastion out to this node. This is one of my nodes in the cluster, to this node port, and then send that back to my local host on 9445. Right? So now what I can do is I can just do a curl localhost 9445. You see there's my cluster. Now you notice I have this -k with HTTPS. Another piece of this cluster is that we have full TLS across the cluster. And this is one of the requirements here in my job where I deal with a lot of patient data and PHI. Data must be encrypted at rest and in transit. So our EBS volumes can be encrypted, and also we can encrypt the traffic between them. So we have some certs that we can define out there on this cluster where you can, again, enable this TLS. Okay, cool. So we now have a working cluster, right? Which is pretty cool. So let's go ahead and take a look at modifying the cluster dynamics, right? So we can go back in here. Now we have this deployed. We can change some things around. So let's scale down our client nodes to 1. Let's scale up our masters to 3, and let's scale up our data nodes to 6. And what this should happen is because we want to spread these data nodes across these zones evenly, speaking that we have 1 in each zone right now, should eventually have 2 in each zone to add up to our 6. So let's go ahead and save that. And then the other issue here is that there's a bug with how kube control apply works with third-party resources. I do believe that has been fixed since then, but I just haven't had time to play with it. So what we're going to do is we're going to run this command here, and we're just going to send a put request. So we're going to send over that JSON file to the API server, and update the third-party resource through a put. So my proxy is running on 8001 right now, and this should be all I need. So after I submit this to the API server, we can go and watch this scale up and down. Okay. So now here you can see that it's terminating 2 of my clients, so I wanted to have 1. It's spinning up 3 more data nodes, and you can see that those are now scaled evenly across my zones, and it's scaled up my master nodes. So you can see this one's 13 seconds old. At the same time, again, with these extra data nodes, it's provisioned me more volumes, more claims, and more persistent volumes. Okay, so what we're going to do is watch our logs, and down here we'll see, we'll be able to see how this guy happens. So right now our cron is set to every 2 minutes. So after these 2 minutes expire, we're going to see that it'll take a snapshot and dump that snapshot out into S3. Okay, cool. So there you can see that the snapshot was created. We can hop back here to our S3 bucket, and we'll see now that we have data. Boom. And there's our snapshots sitting here in the bucket. And this will happily go and keep continuing to create snapshots every 2 minutes. Now, obviously, that's probably too quick for a real cluster. But again, it's totally definable, up to you and how you want to do it. Great. So thank you very much. Again, my name is Steve Sloka. You can find the repo here out on GitHub. I'm Steve Sloka on Twitter. Feel free to give me some comments. Drop me a line on any of the places you feel fit. And hope you find this useful. Thank you very much.